Hello and welcome to this video in the series of bonding. What we're going to be talking about today is we're going to be talking about ionic lattices, following on from the last video we did where we talked about ionic bonds. So in this video we're going to look at what an ionic lattice is. We're going to talk about what the ending "ide" and "ate" mean. So for instance, sulfide and sulfate, what's the difference? And last but by no means least, we're going to talk about how we work out the formula of an ionic compound. Now, just to begin with, it's really useful to remember our definitions. So an ionic bond, what is it? Have a think, pause the video, check back to see if you're right. So what is an ionic bond? Well, an ionic bond is, what is it? It's a strong force of electrostatic attraction between those oppositely charged ions. Now I'm going to leave that along the top because it's a useful thing to always bear in mind. Remembering that those oppositely charged ions are called cations and anions. The cations are the positive ones, the anions the negative ones. Anyway, enough about what we did last time round. Let's get on to what we're talking about this time round. So first off, we've got this idea of an ionic bond bringing together these ions. Now, what do they look like? Well, what they look like is they occupy these lattice structures that look a little bit like this. Okay, or that one, that way round. Okay, they look a little bit like this down here. Now, you can see this is a really nice regular shape. Okay, we call this a regular arrangement of ions. Okay, there's a nice, they're all as close as they can be, and the positive ones are surrounded by a load of negative ones, and the negative ones are surrounded by a load of positive ones. Now, this particular shape is a cube shape. Okay, and one of the amazing things about ionic compounds is they form lots of different types of crystals. Okay, so we've got this idea of an ionic lattice and also crystals. What do the crystals look like? Well, here are some examples. Okay, we've got some cobalt chloride crystals. Here, this one's actually got no water in it, and this one's got some water in it. So there's some different ones there. And here is sodium chloride, the salt that you would put on your fish and chips or whatever meal it might be. So we've got this idea of an ionic lattice, okay, which is a regular arrangement of alternating cations and anions. Okay, and what they do is they form crystals. Now, what you'll notice about all crystals, if you were to observe them under sort of a microscope or look at them really carefully, or see massive ones, and I've put a link in the description below to a video about the Great Crystal Cave, where there are some huge crystals that have grown over thousands of years. What they are is they are structures that have flat surfaces or sides with sharp edges. Now, what I mean by sharp edges is not necessarily like if you were to cut yourself with it, not that kind of sharp, but sharp as in they are sort of very defined. They would be a single line. Okay, that's what I mean by sharp. So that's what an ionic lattice is. Okay, and ionic lattices make really nice crystals. So let's talk a little bit about the next part. What do these ides and eights mean, and how do we actually work out the formula of an ionic compound? So let's talk about how we work these formulas out. What does ide and ate mean? Okay, so first off, we've got this idea of an ionic compound. So an ionic compound is formed in a reaction between atoms, okay, of elements that form ionic bonds. Now, these ionic compounds, they will always be made up of anions and cations. Now, that's important because what that means is that their overall charge will be neutral. So all this is it's a balancing act of charge. Okay, that's what this is all about. So, how do we know what the charges of different ions are? Well, there are two ways. The first is to use the periodic table. The second is, unfortunately, you just have to learn some. And the more complex ones are the ones you just have to learn. But I will give you a list of those. So, this is the first part, finding out what that charge means. So, if we're to look at how we use the periodic table, I'm just going to really quickly draw out a rough periodic table. Be back with you in a second. Right, so here's my periodic table. I'm just going to add hydrogen onto it up the top here. Now, with our periodic table, we know that there are groups, okay, and the groups are the columns of our periodic table. So if I was to write out the groups of the periodic table, okay, we have group 1, we have group 2, we have group 3, 4, 5, 6, 7, and then we have 8, or sometimes also referred to as 0. Okay, now I'm going to add in some other numbers to this. And these are the important numbers. And whenever you get a periodic table and you're going to work out some chemical formula that involved ionic bonding, you must write this down. It will really help you out. Okay, so here we go. This is what it is. This is the magic. Okay, and this is the important bit. +1, +2, +3, plus or minus 4, -3, -2, -1, and 0. Now what you'll notice that those numbers line up with our groups. Okay, so we've got group 1 is +1, group 2 is +2, group 3 is +3, group 4 is ± -4, so on and so forth. Now this is how this works. If you have a group 1 element, okay, the charge on the ion will be +1. Okay, so every single element in group 1, when it forms an ion, okay, it will be a ion with a charge of +1. If it's in group 2, it'll be +2. If it's in group 3, +3, and so on and so forth. Kind of questions that you're going to get Key Stage 3 in GCSE is you're going to get questions involving the ones sort of on the far extremes. Okay, so the +1s, +2s, the -2s, and -1s. Okay, you might even get a +3 in there. So that's one way in which we know what the charge on an ion would be. Now the other is, unfortunately, as I've said, we've just got to learn some. Now, what ones do we need to learn? Okay, right, I'm going to write these in red. So the important stuff that you just need to learn is written in red. This is a list of ions, okay, that you just need to know. So the first one is ammonium. Now, ammonium is NH4+. Okay, next one we've got is nitrate, which is NO3-. Okay, they don't have a number on them because when we use the number 1, we don't need it. Okay, so we just write plus or minus. Okay, we don't need a number there. Another one we've got is hydroxide, which is OH-. Okay. Next one we've got is carbonate, which is CO3 2 minus. After carbonate, we've got sulfate, which is SO4 2 minus, and then we've got sulfite, which is SO3 2 minus. Okay, so that's just a little list of what we call polyatomic ions that you need to know. So you need to know what the elements are within it, but also the charge. Polyatomic just means many atoms. So this is also where our ending ides and ates come in. Now you'll look at a couple of these and you'll see that you've got some that end in ate and some that end in ite. And we talked about last time chlorine and bromine, and they make bromide and chloride. Now the difference between ide and ate is simply if you've got something that's an ide, it's normally just that element. So bromine forms a bromide ion, chlorine forms a chloride ion. However, if we have oxygen as well, the ending will change. So if we had chlorine and oxygen in a polyatomic ion, it would be a chlorate ion. Obviously hydroxide is a bit of a sort of exception to the rule here, but hopefully you can see that here we've got nitrate, sulfate and sulfite, which all have oxygen in the end, and carbonate as well, that's also got oxygen involved in it. If I had sulfide, for example, that would be just a sulfur ion, okay? It would only involve the element sulfur, there wouldn't be anything else. So that's what the difference between ide and ate means, okay? I'm just going to make a note of that up the top, okay? So ate tends to mean that oxygen is in the ion as well. Okay, and then we have that word polyatomic. So, lots of really good information there. We now know, okay, what an ionic lattice is, we know what the crystals are, and we also know how to find out all the charges on those different ions, whether they're simple ions involving one element or those polyatomic ions. And yes, that list, you just need to learn it. Okay, make some flashcards, do something like that, that's what you'll need to do. So how do we combine them together to write an ionic formula? So I'm keeping this information up on the screen because it's going to be useful, and until you actually learn what those polyatomic ions are, you might want to have them there for reference when you're writing formula. So let's say we've got a substance, sodium chloride. Okay, everybody knows sodium chloride, and you probably already know what its formula is because you've probably come across it before. But how do we actually work it out? Well, all we do, okay, is we take some simple steps. The first step is to write down the symbol of the element, okay? So the first thing we do is we write down the symbol. Okay, so we are looking at Na and Cl. Okay, so that's the first step. The second step is to write out the charge. Okay, so the charge on a sodium ion is +1, okay, and the chlorine is -1. How did I know that? Well, sodium is in group 1 of the periodic table, and chlorine is in group 7. Okay, and remembering my numbering rules, I know that sodium has a charge of +1, and chlorine, when it forms an ion of chloride, will have a charge of -1. So what I then do is, after I've done that, is then I balance them then. So what I then do is I then balance them. What's next? Well, balancing them is next. So I've just got to make sure that the overall number is 0. Okay, overall must equal 0. Well, currently I've got +1, -1. +1 is 1, -1 is 0. Okay, so they are already balanced. They're in the correct ratio. So I need them in a 1-to-1 ratio. So therefore my formula is going to be NaCl. Okay, easy. Let's do another one. Okay, let's do a slightly different example this time. Let's look at calcium bromide. Okay, so calcium bromide, I've got my symbols. My symbol for calcium is Ca, bromine or bromide is going to be Br, My charge is this time +2 for my calcium, and my bromine is -1. So now I've got to balance them. So how do I balance them? Well, +2 -1 is still +1. So I need one more minus to make this 0. So I need a 2-to-1 ratio. So then I can write out my formula, and my formula is going to be CaBr, and I use a little 2 to show that I've got 2 bromide ions for every calcium ion. So, a little recap. So we've got symbol, charge, balance, using ratios, and then formula. Okay, SCBF. So let's do a couple more examples where it's a little bit more complicated, and then you'll have a go at doing a few. Right, so next one that we'll do, let's have a look at, we shall do, let's go for lithium sulfate. Okay, so we've got lithium sulfate. Okay, so we've got symbol, charge, balance, and formula. So this time with our lithium, okay, our symbol is Li. Again, I would get that from the periodic table. Sulfate is SO4, and I know that because I've learnt it. My charge is +1. My charge is -2. Then I've got to balance them out. So this time I've got +1 to balance out this -2. So I know I'm going to need 2 lithiums for every sulfate. So therefore my formula is going to be Li with a little 2 SO4. So getting a little bit faster with this. So look at one more example. Okay, I'm going to go for calcium again. This time I'm going to take calcium nitrate. Okay, so we've got a symbol, we've got a charge, we've got a balance, and we've got a formula. So calcium is in group 2, Ca, and it has a charge of +2. Nitrate is NO3, and I know that it has a charge of -1. So, when we come to balancing it, this is nice and simple. Hopefully the balancing, we can work this out. I need 2 nitrates for every calcium to make sure that the overall charge is 0. It's going to be in a 2-to-1. Now, this is where the issue comes in, and this is where the new thing that, just to finish off this particular lesson, we're going to have a calcium. Now, we've got NO3, but I've got to write that there's 2 nitrates. Now, if I was to write a 2 here, all being well-meaning, what I've now actually written is I've written calcium, 1 calcium atom, 1 nitrogen atom, and 32 oxygens. So how do I make it so that it's 2 nitrates? Okay, well, I just add in some brackets. Okay, so I use those brackets whenever we have a polyatomic ion. Okay, and we've got multiples of them, we can use brackets. If there's one of them, we don't need brackets. But if there's more than one of them needed, then we can use brackets. So that's my little rundown on how to work out this balancing active charge and write out some chemical formula. So how about you have a go at a few? So here we go. Here's some questions for you. What are the formulae of the following ionic compounds? We've got ammonium chloride, lithium hydroxide, sodium carbonate, ammonium sulfate, and aluminium oxide. You will need a periodic table for this. So there is a link in the description below for a periodic table that you can use. However, have a go at them, pause the video, come back and see if you're right. So how do we do? Let's have a look. Well, ammonium chloride, okay? Ammonium chloride is NH4Cl, okay? Ammonium has a charge of +1, chlorine has a charge of -1, they balance out. Lithium hydroxide is LiOH. Again, lithium had a charge of +1, hydroxide a charge of -1, they balance out. So sodium carbonate. Sodium is in group 1, okay, has a charge of +1. Carbonate, okay, has a charge of 2-, so we need 2 sodiums for every carbonate. Na2CO3. So on to the fourth one, ammonium sulfate. Ammonium sulfate, NH4 for the ammonium, and the key thing here was to read this as sulfite, not sulfate, so you need to make sure you get it the right ending, which was SO3. This has a charge of 2-, this is a charge of +1, so we need 2 of these. So we need to put brackets in here and write a little 2 in there. Last but by no means least, aluminium oxide, slightly trickier one. So if I was to write out my little sort of framework, I'd have aluminium and oxygen. Aluminium has a charge of +3, oxygen has a charge of -2. We need to get this balanced out so that they're in the correct ratio, so that we get the overall charge of 0. A little bit of trial and error. Okay, this is not balanced. Okay, but then if I put 2 oxygens, it's still not balanced. So then I'd need another aluminium. So basically what we need to do is we need to move these numbers up until we have the lowest common multiple, LCM, little bit of maths in here, of those 2 numbers, which is 6. Okay, so I'm going to have these in the ratio of 2 to 3, which means that my formula at the end here is aluminium Al2O3. Right, so again, lots more information here, lots of really good chemistry with this ionic bonding coming on. What we've talked about in this video, we've talked about ionic lattices, we've talked about what an ionic lattice is, we've talked about what the endings "ide" and "ate" mean, and we've looked really closely at how we can work out the formula of an ionic compound, balancing active charge. Where do you find out the charge on those ions? Well, the first place is the periodic table. The second is you just have to learn some, and here's that list. Make some flashcards, and then we've had a go at doing it. And hopefully you've had a good attempt at those last few formulas. Okay, so thank you very much for watching. Please like the video, subscribe to the channel if you haven't already. Your support is greatly appreciated. So, as always, I'll catch you in the next video.